All right, we have a new diagram. Okay. Can we do anything with this diagram in terms of variable length subnet mask? So it's really tricky, right? Okay. Just study it for a while and give me your thoughts as to how we should proceed. All right. Now that you've studied, let me ask you whether or not we should use traditional subnetting or variable length subnet mask. If we use traditional subnetting, we have to, the first step is, according to the instructions, determine the required networks. We need to count the networks, right? Let's do that. Okay, how many networks are there? 2 networks? Is that right? Look at those router interfaces. I need you to be aware of this particular rule. Okay? Remember broadcast segment. If it shares a broadcast segment, it's on the same network, same local area network. We'll come back. All right. Let's see if we can position that. All right, let's do some counting. All right. This is obviously one network, right? This is one network, right? Okay. All right, so that's one network. Where's another network? Okay. So we'll say this is network number 2. Okay. It's a little tricky down here, right? Okay. Recall this statement. Interfaces that share the same routed link or broadcast segment. Okay. Let me ask you this. If I were to go into this router, right, and send a ping down this interface, where would that ping go? And we're assuming that the ping is a broadcast. It's a broadcast ping. If I were to ping 255, 255, 255, 255, the ping will leave the router, go down this link, go to the switch, and the switch will send it where? Oh, it'll send it to the laptop, the server, the printer, and this router, right? It's going to everything because, you know, switches don't break up broadcasts. So in essence, well, you know, if we look at this rule here, all of these devices, these 3 devices, this interface and this interface are on the same network. Because it says that they share the same broadcast segment. It means that if you send a broadcast out, it'll hit every device on that broadcast segment. Hence, those devices on the same local area network. So this is one network. All of these interfaces are on one network. Okay, it's a little tricky.
Even the WAN connection.
No, not this. This is network 2.
Now, when you set up a broadcast,
hold on just a second. Okay, I'm going to label the links. This is part of the third network. This one's part of the third network. Third network. Third network. Third network. So so far we have 1, 2, 3 networks. right? All right, let's deal with these links. Imagine sending a ping from the PC, a broadcast. You're going to ping the broadcast address. Where will that broadcast go? It'll go to those 3 routers, these interfaces. So hence, this PC, those 23 PCs, and 1, 2, 3, the 3 router interfaces are on the same local area network. So we have 4 networks, right? 1, 2, 3, and 4. Okay, question? Okay. Now that we've determined that we have 4 networks, okay, and we need to ask, do we need to use traditional subnetting, or should we use variable length subnet mask? If we use traditional subnetting, we need to borrow how many bits? So it's going to be 2 to what? 2 to n, and n is going to be network bits. How many bits do we need? 2 to the second power is 4, so we could borrow 2 bits, right? If we borrow 2 network bits, then we have 6 host bits left, right? Then we need to determine the host range, so it would be 2 to the 6th power minus 2. That'll be what? 2 to the 6th power is 64 minus 2 would be 62. So that means if we have 4 networks, we have 62 hosts on each network, right? But then, you know, we have 1 network here, which is network 1 with 2 hosts. You're going to be wasting a bunch of host addresses. So we don't want to use traditional subnet. We want to use variable length subnet mask again.
That's in most cases.
In most cases, yeah. Yeah, in most cases you want to use variable length subnet mask.
Now what about like